In this video, I'm going to demonstrate the behavior of this RLC circuit when suddenly we change the switch from one position to the another position. So that is called as the transient analysis of RLC circuits. Consider this case. In the circuit shown in figure, switch S is changed from position A to B at t is equal to 0. At t is equal to 0. Steady state condition having been reached before switching. Before changing from A to B, it is steady state has been reached. Find the values of I, di by dt and d square I by dt square at t is equal to 0 plus. So this is the one we have to find. What actually we have to find? I di by dt, d square I by dt square at t is equal to 0 plus. Yeah, so coming to this circuit, it has one voltage source, a DC source 40 volt, one inductor, that is a 1 Henry, and it is a resistance of 20 ohm and 1 microfarad capacitor. So these are the three elements and with a source. And here is a switch, yes. Initially what it is saying that it is at switch is changed from A to B at t is equal to 0. Means before changing from A to B, it was there at A. So we will analyze the circuit now. So when the switch is at position A and at t is equal to 0 minus, means before changing from A to B, what happened to this circuit? Okay, that analysis we have to do. So when the steady state is reached, when the steady state means before changing from A to B, the steady state is going to be reached. What is the meaning of the steady state? After steady state, what happens when it is in position? Current will be start flowing and the capacitor is start go on charging, and up to what level it is going to be charged, whatever the source is there, up to this volt, the capacitor is going to be charged. Once it is fully charged, the voltage across this capacitor is also equal to 40 volts. That is a one mega. When capacitor is fully charged with capacitor voltage, that is of 40 volts, and the current in this means once it is charged, these two are same. So then current will not going to flow in this circuit. So that is a summary. When it is a steady state is reached and at position A, VC of 0 minus is equal to 40 volt and IC of 0 minus is equal to 0 ampere. And even VC of 0 plus, so that is also, we will see, okay, 40 volts and IC of 0 minus is equal to 0 ampere. Now, at T is equal to 0. So now this one, now it is going to be change here, change. We are going to change here. When we suddenly change from A to B, inductor always opposes. It will always oppose. It looks like something like that. Okay, I'm open circuit. So that is the one I have written here. When we change, sudden changes always inductor opposes. Once it has a high impedance, something like that we can say it as an open circuit. That is at t is equal to 0 plus. When we redrawn here, this capacitor now I'm going to replace with the voltage source. It is of a 40 volt. That is IC of what actually the voltage here. This is the voltage across the capacitor. So this I can write it as. So VC of 0 plus, it is nothing but a 40 volts here. VC of 0 plus is 40 volt. Now at t is equal to 0 plus. So this is the circuit here. Inductor will come at t is greater than 0 plus. I will write the KVL for around this loop. Ri, R into I, L here, L into di by dt, capacitor here, 1 by C, integral of I dt. This is the KVL around this loop, and also I am going to call it the equation 1. And R, I of 0 plus, I already said that is the current is 0 because it is opposite. It acts as an open circuit. L into di by dt 1 by C I dt. So this again, this term L is 20. So what actually 20, sorry, this is a 20 ohm into I of 0 plus it is a 0. L value is here, L is a 1 into di by dt 0. And this term, it is a 1 by C I of 0 plus, this is a capacitor voltage. Vc of 0 minus Vc of 0 plus is 40 volts. So that I have written here. And di by dt of 0 plus, this term is 0. And this I am taken to the right side, minus 40 ampere per second. So this is the di by dt. Next is the d square I by dt. Take this equation again. One more time I will differentiate. That is a differentiating. R di by dt, this L d square I by dt, this is the integration here. That I am writing it as I by C 0. Substituting initial conditions, di by dt of 0 plus L d square I by dt of 0 plus I of 0 plus by C. This I of 0 plus current is 0. Yeah. Then R value is 20 ohm. Di by dt is minus 40 ampere per second. L is 1 Henry. D square by this term is 0. Then d square I of dt square 20 into 40. So when I take into the right side, it is a 800 ampere per second square.